Today topic is LR parsers, an efficient bottom-up parsing technique that can be used to parse a large class of context-free grammar is called LRK parsing. Here K means K input has to be there. If K is missing, then by default the value of K will be 1. L means left to right, and this right means rightmost derivation in reverse. That's why this is known as LR parser. Advantages of LR parsing: it recognizes virtually all programming language constructs. It is an efficient, non-backtracking, shift-reduce parsing method. A grammar that can be parsed using LR method is a proper superset of a grammar that can be parsed with the predictive parser. It detects a syntactic error as soon as possible. Types of LR parser. First one is SLR, simple LR parser. This is easiest to implement, least powerful. Second one is CLR, canonical LR parser, most powerful, most expensive. LALR, look ahead LR parser, intermediate in size and cost between the other two methods. This lies between this and this in the complexity, cost and size. The LR parsing algorithm. The diagram of all LR parsing is same. So it uses a LR parsing program which reads the data from the input buffer. There is a stack on which S0, X symbol are stored. S is a state and X is the grammar symbol. It produces the output that the string is parsed or not, or error, and it uses the parsing table. It has two parts, action and go to. Input. So algorithm of the LR parser: input and input string W and LR parsing table with action. The parsing program determines SM, the state currently on top of a stack, and AI, the current input symbol. It then consults action SM, AI in the action table, which can have one of four values. First one, shift S, where S is a state. Second is reduced by a grammar production, A produces beta. Third is accept, and fourth is this error. Then calculation of go to. As I have already told you, parsing table has two parts, action and go to. Action will be calculated like this, and go to, it takes a state and grammar symbol as arguments and produces a state. LR parsing algorithm. Input and input string W and an LR parsing table with functions action and go to for grammar G. Output is W is in LG, a bottom-up parse for W, otherwise an error indication method. Initially the parser has S0 on its stack, where S0 is the initial state and $, is the input buffer. Parser executes as below. Set IP to point to the first input symbol of $. Repeat for your begin. Let S be the state on top of the stack and A the symbol pointed to by IP. If action SA is equal to shift S, then begin push A, then S on top of stack. Advance IP to the next input symbol, and else if action SA, this is equal to reduce A to beta, then begin pop 2 into mod of beta. Mod of beta means length of string beta, symbols of the stack. Push A, then go to S, A on top of stack. Output the production, A produces beta, and this is end. Else if action S, A, this is equal to accept, then return else error. And that's all about this algo, and that's all about this lecture.